This is a practical and stable AC-coupled system without UPS functionality. It includes photovoltaic panels, a photovoltaic inverter, a liquid-cooled battery system, a grid breaker, a grid meter, a transformer, a 35 kV utility grid, and loads. A key feature of this system is that the battery system, PV inverter, and loads are directly connected to the AC busbar. Usage Scenario 1. Grid-powered scenario. During the day, under sunlight, the photovoltaic panels convert solar energy into DC power and input it into the PV inverter, which then powers the load. Excess power can also be used to charge the battery. When the battery is fully charged, the inverter stops charging the battery and boosts the excess power through the transformer to be transmitted to the grid. If the grid prohibits electricity sales, the photovoltaic system only supports the load. At night, when electricity sales are permitted, the battery can support both the load and the grid. Otherwise, the battery only supports the load. When the battery is nearly discharged, the EMS controls the battery to stop discharging and allowing the utility to support the load. Usage Scenario 2. Off-grid scenario where the power grid is out of power. During daytime power generation, PV power generation exceeds the load. PV power supports the load, and the excess power is used to charge the battery. Suddenly, the mains power goes out, and the mains circuit breaker automatically trips, shutting down the PV grid-tied inverter, the energy storage PCs, and the load. When the EMS detects the mains circuit breaker trip, it switches the energy storage system to off-grid mode to support the load. After approximately 5 seconds, the grid-tied inverter restarts, supporting the load and charging the battery. When the mains power returns, the EMS detects the restoration of mains power and first switches the energy storage PCs back to grid-tied mode. The load and grid-tied inverter are disconnected again, and then the EMS closes the grid breaker, resuming normal system operation.